In the last video, we talked about the Diels-Alder mechanism and the general reaction scheme. So that was the Diels-Alder 1 video. In this video, I'm just going to go through two examples of Diels-Alder reactions. So the question is, what Diels-Alder products are formed? We have two different reactions here, two different sets of reagents. Anytime you're going through these types of questions, I recommend first identifying which molecules you're diene and which molecule is the dienophile. In the first example, we have, again, 1,3-butadiene. So this is going to be our diene, and this molecule is our dienophile. So we know that the dienophile, wherever that carbon-to-carbon double bond is, those two carbons now add to carbon 1 on the diene and carbon 4 on the diene. If it helps, we can number the carbons. We can even draw out the mechanism where we have carbon 4 creating a new bond to the dienophile. Dienophile creating new bond to carbon 1. And a new pi bond between carbons 2 and 3 on the diene. And so this forms a final product where we have, drawing out the carbons in the diene first, new pi bond between carbons 2 and 3, and new bonds to the carbon atoms, which I'll draw out with C's, from the dienophile. So now this carbon is bonded to 2 hydrogens. The carbon on the top is bonded to a hydrogen and that ester group. And there's the product. In the second example, we will first identify the diene and dienophile. The diene is a ring this time, and then we have our dienophile with 2 nitrile groups. So when the diene is already a ring, the product that you'll form is called a bicyclic compound because we are forming another ring, but the diene ring doesn't break. So we'll have 2 rings in the product. We can number carbons 1, 2, 3, and 4 on the diene just to help us identify where the new bonds are going to occur. In the product, I'm going to draw the diene a little funky. I'm just going to add that last carbon kind of pointing in. So here's carbon 1, 2, 3, and 4. This makes it easier to show that the new bond to carbon 1, we can show that down here. And the new bond to carbon 4. So here, let's highlight the carbons in the diene. Here are the 5 carbons in the diene that are now in the product. And then if we do the same thing with the dienophile, those atoms are over here. And so we have what I mentioned as a bicyclic compound where we have 2 rings present in this molecule now. If it's still unclear where the different atoms are bonding, where bonds are breaking or bonds are forming, pause the video here and try to trace for both of these examples where those new bonds are, and you'll start to see a pattern that I've described where the electrons in the pi bond in the dienes form a new bond to each of the carbons in the dienophile, and the pi bond in the dienophile forms a new bond to the diene as well, and that's how we get that cyclic product.